what are you supposed to do when you have an instruction like f of -5? Plug it in. Plug in -5 for x. Okay, so this is saying that x is the same as -5. You can see just aligning things here. We have the f, and you can see that the -5 is literally in place of the x. All right, that's how that notation works. And so we say, hey, take that -5 and plug it in. So you said f of -5 equals, what was it? -17. Okay. So what I want you to understand is that when we have function notation like this, we use function notation in upper math a lot. And the reason is because we get an input and an output. And so we can see what number we plugged in and what it spits out when you plug it into the function. And the reason that's super important is because not only does it give us a value, but it's also an ordered pair on a graph. It's an ordered pair on the graph of the function as well. The input and output, or otherwise known as your x and y. Okay? And that's really important because we want to be able to interpret function notation graphically as well. So here we go. I am going to give you guys a couple minutes to make a sketch of the graph. It doesn't have to be beautiful. Just make a rough sketch, and then you can, we'll put down the points in a little bit.
Two.
They have 2 legs. Hey, it wasn't an question.
Is this like a vote?
They don't have it.
Oh, shut up. Legs are Android chargers.
I guess you have more, but like, yeah, like,
Can we discuss how to narrate? Can we discuss this?
You're drawing the graph. You're writing down the picture. Draw the graph. Make a sketch.
Birds are literally the most terrifying animals.
Sketch the graph.
Yes.
I personally I think we should just have an answer. I think we should go back to it. Like a king and
Make a sketch. Like you've got a slanty line here, you got a piece of a parabola there, and another line, horizontal line. Make it quick. It doesn't have to be gorgeous. We'll put some numbers and stuff on there later. Yes. So this is an open circle, solid, open. Can I get that way for you? While you guys are finishing up, I'll give you about 1 more minute. On the wall, you see some thank you notes. So you remember I told you about getting all the graphing calculators? Bigly. I put in a donor shoes, and I got an award by like Korean pop group with like all their army. Like, right? You remember that?
That's the funniest thing I've ever heard. I'm sorry.
I have to send out thank you notes, and they're like, your students should send a personal thank you note. I'm like, I'm not the one giving out the calculators to the students, right? The calculators are going to the finance office, and any student on campus can check out a calculator and use it for the remainder of the year. So today, you guys will have plenty of time, but but I'm gonna put up some more as well. What I would love for you to do is go and just sign and write a little blurb like, your generosity is amazing. We're humbled by your generosity. Or thank you for helping us out, or something like that. And just put your first name, not your last name. And what I'd like you to do is just sign. They'll be stacked on top of one another. I need basically 2 copies. So if just sign one of them, the top and the bottom one. Does that make sense? There'll be 2 stacked on top of one another. I just put the same thing on both. Yes. If you don't have to sign all of them, just pick a pair to sign. That'll be all. All right, thank you so much. Okay. I'll remind you again later. That'd be super. Okay, here we go. So here, what I have is this generic function f that I pieced together, also known as a piecewise function. This is a solid dot, and so is this. And what we want to find is f of -4. Again, what does that mean? What does f of -4 really mean? X is -4. And so we go to the x-axis, and we go to -4, and we ask ourselves, what's the output? -4. Yeah, the ordered pair is for -4. The input is -4. The output is -4. We go f of 0. What's the output? Oh, -4 again. We go to 0 on the x-axis. And there's the output way down here, 0, -4. So you can label your graph with those ordered pairs so you can see where all these numbers come from. F at -1. What's the output? Good. We go to -1. The output is down here on the graph. -1, -3. F of 3. 2. Very good. We go to 3 on the x-axis, and our output is up here. The ordered pair, 3, 2. 3, 2. F of -3. 5. Good. So that's a little trickier. -3. Do we go down? Do we go up? How can we go up? Because that's an actual point. Yes. Versus down here, which is, it's a pretend point. It's not included. All right. Close, but no cigar. So -3, 5. And then F at 2, 0. At 2, our function value is 0.
Wait, why can't you do 2, 2?
Why can't you do 2, 2?
Because it's a circle? It's not there.
It's not included. It's not actually there. Yep. Okay. Hopefully that was easy. We're not doing this today. We're doing this. Here we go. We're doing this. Example 2. Evaluate the function at each specified value of the independent variable and simplify. So today's worksheet was ridiculously easy. So
Don't underestimate my stupid.
Oh no.
I'm failing. I say that, but I'm
evaluate the function at the specified value of the independent variable and simplify. You need to get really good at this because we're going to be talking about the difference quotient tomorrow. Yeah, it's not Friday. Yeah, we got another day. Okay, here we go. Here we go. Ladies and gentlemen, they want me to find f of 3. How do I do that? Plug in 3 for x. This means that x is in place, or 3 is in place of x. And so we're going to take our function, and everywhere we have an x, we're going to plug in a 3. What do we do first if we have to simplify this? Exponent. And what is 3 squared? But there's this negative hanging out in front, so it's really a negative 9. We can multiply. Negative 4 times 3 is negative 12 plus 7. And what do we get? Negative 14. Negative 14. There we go. Good. All right. Very good. Very good. Okay. So now those are easy. These get a little more difficult. You can imagine what sorts of things I'm going to ask you on a test. Okay. All right.
Wait, is that gonna be on the test?
What? Okay. All right, ladies and gentlemen, letter B. What do we need to do?
Bless you. I'm so sorry. Like in high tea. Like in high tea.
Oh, first period is so nice and quiet.
That's because they're all tired and probably sleeping.
She just.
All right.
She said I hate y'all.
There was no coded message in there. Not like my optometrist last night.
Hey, what did they do?
My optometrist last night, he was like, I'm just thinking in the next few years, we're going to have to start talking about the bifocal issue.
Oh.
And I was just like, okay, you just called me old.
Don't worry, Miss. I have put 5 levels. Now you have 16.
Sorry, bifocal is like this. Look, I can't. I need 5. Yeah. No, I don't really yet, but he was alluding that I might. Oh man, the dreaded 40. Okay. All right, here we go. So yes, ladies and gentlemen, we're taking the x and replacing it with a 5t. So once again, what do we do first? Square it. What is 5t quantity squared? 25t squared with the negative minus 20t plus 7. Can I combine any like terms? Nope. F of 5t is equal to all of that. All right. Last and certainly not least, what is this telling me to do? Plug in s plus 2 in place of the x. So again, in place of the x, we have an s plus 2. It needs to be squared. Minus 4 times s plus 2, and then plus the 7. Problem number 1. We have to do the exponent first. Is s plus 2 quantity squared? S squared plus 4?
No.
No. What do you have to do? S plus 2 times s plus 2. Foil that out. F-O-I-L. First, outside, inside, last. And when we foil, what do we get? Good. S squared plus 4s plus 4. 2s plus 2s is 4s. Now, there is still a negative out in front of all of that, so be careful. I am going to go ahead and distribute my negative 4. So I have a negative 4s minus 8 plus 7. I need to distribute my negative. Negative s squared minus 4s minus 4. Minus 4s minus 8 plus 7. And then I can just combine my terms. Negative 4s and negative 4s is negative 4 and negative 8. And positive 7 is good. And we don't, just making sure we don't divide by s plus 2 on both sides and solve for f. No, you don't. You're done. We're not solving, we're simplifying. So please be careful. Okay, that is all. Do you have any questions for me?